Good morning, good afternoon, good evening, good night, wherever you are. Welcome back. Today we are going to hold a relatively short video on kind of review of the last few videos that we have seen. This one's really going to be entitled Algebra Wrap Up. So I've selected a small number of problems which are representative of the material that we have covered. And those problems are, I like to call them test-like. So they reveal more or less the level at which we will actually see the problems on our first midterm, and most likely our only midterm. So without any further ado, let us take a look at example 1. Example 1. So these are difficult problems. So 3.5 stars. So the labeling of it is pretty much always the same in terms of how we call them. We call them simplified problems. So here's the expression. It's 3x squared times x squared plus 1 squared minus 4x cubed, no, 4x4, sorry, times x2 plus 1 over x2 plus 1 to the power of 3. All right. So let's take a look at this, ladies and gents. Let's take a look at this. What is your first reflex when you see this? I know some of you would probably be tempted by this. There's a square. Let's expand x squared plus 1. So x squared plus 1 times x squared plus 1 get a trinomial. Multiply this by 3x squared, multiply these in, and see if we can simplify. That is the non-advisable course of action. What is much better here is to try to see if we can simplify the expression before we expand. Now, notice, just to mention, x squared plus 1 squared, x squared plus 1 cubed. Can I cancel the x squared plus 1s up and down here? Can I do that? The answer is no, because this term is actually linked to the other term with a negative sign. It's not, it looks like it's multiplied, and in fact it is multiplied by 3x squared, but it's also subtracted with another term, so it is not free to cancel. So what is the best way to tackle this? The best way to tackle this, as some of you may know, is to try to see if there is anything common between those two terms. Is there anything common between this and that? And the answer is certainly. There is an x2 because x2 and x4. There is also an x squared plus 1 to the power of 1 because we always take what's common with the least power, and that's a power of 1. That can come out as a common factor. Now, what shall we have left? That is a good question. Whatever we have in this square bracket, it will all be over x squared plus 1 cubed. Now, you see, the advantage of doing this is that now I got an x squared plus 1 here, which is multiplied here and multiplied there. It is no more added or subtracted to anything. So it's going to be free to cancel with this guy. Okay. Now, what shall I put here? So in between the two, there's going to be a negative sign, that's for sure. Why shall I put right here? Well, we know how this works because we've seen it before. It's 3x squared, x squared plus 1 squared. I rewrote my first term, and I'm going to divide this by what we decided upon to be the common factor, x squared times x squared plus 1. X squares are gone. I have a 3 left. And then I have x squared plus 1 squared over x squared plus 1. Subtract the exponents and you have x squared plus 1 to the 1. And that's what goes in here. Now what goes in there? It's all about the second term. So this time we go 4x to the 4 times x squared plus 1 divided by x squared times x squared plus 1. Right? So x squared plus 1 once again. Whoa, x4, x2. Subtract the exponents. 4 minus 2, that's a 2. So that's 4x2. Great. So you see that factoring out this common term right here will save me from a huge expansion with large exponents, and then will also furthermore provide with the following simplification, right? Good. So here we are. This should be equal to x squared. What do I got here? Then I can open my brackets and see if I can cancel anything at all. So that will be 3x squared plus 3 minus 4x3. Tutta la familia divided by x squared plus 1 squared. Perhaps I can take out something from inside the bracket here. Do I have like terms? Yes, I do. 3x squared minus 4x squared, that's minus 1x squared. So I think we're getting darn close to the final answer. That'll be 3 minus x squared over x squared plus 1 squared. And that's going to be my final answer. Why? Because I can't do much with 3 minus x squared, can I? That is not a difference of squares, for 3 is not a perfect square. So that's my final answer. And here we go. So that is what we call, in the language of Léger's class, a TL problem. TL for test-like. Yes, this is a test level or test-like problem. Good. I have a couple more of the same caliber. So let's see if we can take a look at them as well. All right. Next one. Next one. Always. Example 2, always 3.5 stars. And we want this time to simplify the following expression. 1 over t minus 1 plus 1 over t plus 1. All of that jazz divided by 1 over t minus 1 over t squared. All right. Well, that's what we call, for sure, without any doubt, a complex fraction, because we have not 1, not 2, not 3, not 4, but 5 fractions involved in this problem. 1, 2, 3, 4, and then the global thing is a fraction. So this is going to require major simplification before we can actually attempt at a final answer. So what shall we attempt as a simplification? Why don't we deal first with the numerator? What can we do with the numerator? So this expression could be equal to what? I got a fraction plus a fraction. How do I add fractions? Common denominator. So let me have here a common denominator of t minus 1 times t plus 1, right? Multiply the two denominators. That gives you a common denominator, right? And then crisscross. So 1 times t plus 1 plus 1 times t minus 1. We could put brackets here, but it's not really necessary. All of this, and that is the equivalent of my top fraction. All of this is to be divided by, now let's do something about the denominator. What could we have in the denominator? Well, here we can make a distinction between a common denominator and a least common denominator, because I got t and I got t squared, right? So the least common denominator is t squared, for sure. But you know what? We've got a way to do this. Let's stick with it. It's a little longer, takes one step more, but we will not stray away from the method we have. That's the idea, try to be consistent. So common denominator is t times t squared. So that would be t cubed. And then crisscross. 1 times t squared is t squared. 1 times t is t. And there you have it. So what is that equal to? All right, in my numérateur, what do I have in my numérateur? Let us not expand the bottom, t minus 1 and t plus 1. Let us keep them as they come. In the numerator, t plus 1 plus t minus 1. And that is just 2t in the top. In the bottom, what do I have here in the bottom? Well, t squared minus t, they're not like terms, can't do much except perhaps take out a t. And that's the move we would not have to do if we had taken the least common denominator. But let's not worry about this too much. We take out a t, and then we have this, t over t cubed, which will, of course, cancel into what? So 2t over t minus 1, t plus 1. This shall now be divided by t, and t cubed is t squared. So t minus 1 divided by t squared. You still with me here? This is now big numerator divided by also fairly big denominator. Okay, what would you do now? This is still a complex fraction. It is a little simplified from the beginning, but it is still a complex fraction. Now what would you do on this? What about taking care of this division bar and changing this division to the multiplication with the reciprocal? So that would be 2t over t minus 1, t plus 1. And then instead of dividing by this, let's multiply by the reciprocal of the fraction under the division bar. So t squared and t, yeah, that's correct, t squared over t minus 1. So you take that fraction, t minus 1 over t squared, and you flip it. Good? So, when all is said and done, I do believe we have something that is as simplified as can possibly be. 2t times t squared would be 2t cubed over t minus 1 times t plus 1 times t minus 1. So t minus 1 times t minus 1, that's t minus 1 au carré squared. And then I'm left with the t plus 1, and then I have it. That is the utmost simplified version of the answer for this problem. 3.5 stars. Also test-like or test level, should you prefer. The reason why we're holding this extra video on wrapping up the algebra is that I want to give you a little overview of what awaits you on your midterm, and B, you can test yourself, see if you can actually solve these problems more or less on your own when you review them, because if you can, then you have absorbed the information that's been passed on to you over the last few weeks, and that means that you are absolutely on the right track to get ready for the midterm. On the other hand, if you encounter difficulty with the solving of a problem like this, that means you need more practice, and more practice can actually be obtained from the uploads that I made on Leia, where the supplemental problems are there for you to actually practice some more. Good. All right, I got one more, and this one is, like so very often, taken straight from calculus. So let me just change example 2 to example 3. And the other parameters are the same. It's still 3.5, and it's still test-like. All right, here comes example 3, the last one for this shortened video. So, simplify. What do we got here? 1 over x plus h squared minus 1 over x squared, all divided by h. All right. Once again, complex fractions, 1, 2, and 3. How do you suggest we tackle this? Well, if you're thinking, let's do something with the numerator, then I would agree with you. For this is a fraction minus a fraction, taking a common denominator should actually get us closer to the answer. So, that's a common denominator for the numerator. Once again, the safest way to do that, and we have always done the same thing, is to multiply the two denominators together and then do the crisscross. So x plus h squared times x squared, that's my denominator. And then for the crisscross, so here comes x squared minus the other, this times 1, x plus h squared. We're going to need a bracket here, obviously. And that accounts, mesdames et messieurs, ladies and gentlemen, that accounts for the numerator. All of this is yet again divided by h. All right, so it seems we made it worse. It looks actually less simplified than the expression we had before. But that is not necessarily true. But let's see if we can do something about that ugly numerator. So it's still over x plus h squared x squared. And let us expand what we have here. X squared minus x plus h squared. Can I point out a common student mistake? I see students doing this, x squared minus x squared plus h squared. Distributing the square onto each, is that correct? Nah, that is wrong. That's not the way we actually expand a binomial. So this is, no good. So there's a good way of doing this, and that's not it. So what's the good way of doing this? X squared minus, well, the only way of doing this properly, ladies and gents, is actually to write x plus h squared, as you know, as x plus h times x plus h, which is now x squared plus xh plus hx plus h squared. Those two are the same. So that's x squared plus 2xh, or hx, doesn't really matter the order since multiplication is commutative. That is the way to write x plus h squared. So that's what we're going to put here in a bracket. X squared plus 2xh plus h squared. Good. All right, so there was a little trap here. We didn't fall into this, and now we are going to take the negative inside here. So minus x squared minus 2xh minus h squared, tutti quanti divided by x plus h squared x squared. And now you've seen me do that little trick a couple of times already. I'll do it again because it worked for us before. I will change this division into what? Divide by h is the same thing as multiplied by the reciprocal of h, which is? Why is this? Because h is the same as h over 1. So the reciprocal of h over 1 is 1 over h. So we multiply by 1 over h. Dun, 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 dun. Gone, gone. I seem to be left with minus 2xh minus h squared all over that. Anything at all that I can do about minus 2xh minus h squared? Anything at all? Like take out an h? Sounds good. Take out an h and get minus 2x minus h over, nothing changes in the bottom, times And here's my last cancellation of the day. This is gone with this. Why can I do this? Because this is multiplied by the bracket and not linked through a plus or a minus. I could take out a minus from that bracket or leave it like this. Doesn't really matter. Final answer for full marks shall look like this. Minus 2x minus h over, I can put the x square in front, I can put it in the back. It does not matter. This is the expression we want. That, ladies and gentlemen, is taken straight from Cal 1. We actually here are one step away from finding what's called the derivative of the function 1 over x squared, something we'll see later on in Cal 1. So again, a test-like problem. So if you can do those 3 problems today by yourself with no difficulty, without consulting your notes too much, you know that you've been absorbing the material of the past couple of weeks. If not, more practice is required. That's the purpose of this video, and that purpose hopefully is made. So stay well. I will see you when I will see you. Take care. Bye.